Hello, I'm Jarso Dida. This is to present multimedia data processing task 3. As the given task is audio processing. From the audio processing, I implemented speech motion recognition using convolutional neural network on the dataset named speech motion recognition dataset. As general, now these CNN models we load the data, which is audio file from the data set, and then classify or detect the emotion on speech. This emotion is sad, this emotion is happy, this emotion is surprised, this emotion is disgusted, like that. It detects the emotion within that audio files. Uh, when I start by stating the problem, these speech-based systems are very important to understand human emotions in various domains. They are very important. Here, as speech-based technology continue to expand in areas like customer service, healthcare, and virtual assistant, recognizing emotion from vocal input. The layers of CNNs are there. There is input. Then from that input, by applying many layers, it will detect emotion within that files. Now, what is the problem? First, before this, what is the problem which motivated me to do this project is that yet many current systems or many traditional systems struggled to accurately detect emotions, struggled or faced a problem to accurately detect emotions. Why? Because particularly in presence of diverse accents, fluctuating speech speeds, and the ambient noise. So because of those things, many traditional systems or many current systems struggled to accurately detect emotions. Now, the purpose or the aim of this project is to overcome, to fix, or to solve these obstacles by building a reliable speech emotion recognition models using convolutional neural network, which is capable of, which has ability to identify emotion as happiness, sadness, anger, fear, disgust, calmness, and others. When I say this, let me say something again from the dataset. As I tried, I use it, as I said, I use it, speech emotion recognition dataset, which is one of the dataset from Kaggle dataset, which shows collections of audio files, which has file extensions of .wav. The dataset includes .wav files of various lengths and bitrates, each corresponding to a specific emotional level or emotional level. And the different folders are there, like those things, Crema, Save, Things, Ravdes. Different folders are there, which includes different files. Now, the goal is to extract features from these audio files that will help in training a machine learning model capable of predicting emotions. So I have used this data set, which is spot emotion recognition system. The others are implementation steps. Implementation steps. This implementation steps started by downloading the dataset from Kaggle dataset and uploading them to Drive. Why uploading to Drive is important is that to easily manage and access large dataset during training. As many projects I have done before on many assignments, yeah, I do the same. I have downloaded the dataset, then uploaded to my Drive to easily manage and access the large dataset, especially during training. Then mounting the drive. Mounting the drive is why it is important is that to connect Colab to Google Drive. So files can be accessed directly from the mounted paths. As here in this program, this is Google Colab notebook, which I have implemented, where I have implemented my uh, implementations. This is program for mounting the drive. Then the next step is loading in the pre-processing the data. Loading in the pre-processing, loading the data set. After drive is mounted, the next step is loading audio data from speech and motion recognition dataset. This is done by reading all audio files from the dataset and loading them using Liborsa, which is Python library for analyzing audio signals. These files contain a speech sample that represents various emotions, and the audio files are then stored in array for further processing. Then this data will be pre-processed before training, the model on the dataset. After pre-process, we have to reshape, we have to make ready this dataset for training. The raw audio files are pre-processed into form that the model can understand. This involves extracting MFCC, which are common used features in speech processing. So now, as general, the purpose of pre-processing is normalizing or reshaping the data to match input requirements. So to match the input requirement to convolutional neural network. Then the next step is building CNN model. The model is built, which consists of layers like convolutional layer. This is one-dimensional CNN. There is convolutional layer 1, maximum pooling layer 1. So there is no convolutional layer 2 like that. This is what architectures looks like. This is input, then convolutional layer 1, maximum pooling, input to take the audio files, convolution to extract the features, pooling to downsampling or for compressing without losing important features, then fully conducted layer to detect the emotions. So those are what this is the architectures. And the training the models for 20 pouches. Look here. This is for mounting. This is for loading the data and the pre-processing the data. This program is for loading and the pre-processing. Okay, and this is for building. As you can see here, one dimension, convolutional one dimension. There is no, as I have said, my model is one-dimensional model. Then this is for training. Training, as I have said, model trained for 20 epochs with nice accuracy of 96 something. Here, training. Then next to training, evaluations. Evaluation is there. After training, the model is evaluated on separate test dataset. Now, the dataset is separated on program. Separated as test dataset and the training dataset. From my dataset, 80% is training data, and the 20% is for test. Now, evaluation is done, or what? Evaluation is done on this test data set, this 20% data. And also metrics such as accuracy, yeah, on that test data set, metrics such as accuracy and loss, training accuracy, training loss, validation accuracy, validation loss are used to how well the model generalize the unseen or this test data. The evaluation process helps to ensure that the model is not overfitting or not overfitting the training data. Training data. Now, this is to evaluation, evaluating the model, training accuracy, training loss, validation accuracy, validation loss. And at the end, after evaluating, I plot accuracy in the loss curve. This is what the curve looks like from the program, as you can see here, plotting training accuracy and the training loss, and the validation accuracy and the validation loss. Accuracy, validation accuracy, and the training accuracy, as you can see, just increasing, and the loss is almost coming to zero. And the comparison between actual data and the predicted data, they are almost the same. My time is limiting me. This is all. Thank you. Thank you. Bye.